So now we are starting with the third lecture of coordinate geometry. Lecture number 3, CG. CG stands for coordinate geometry, and we are talking about the coordinate geometry with respect to a straight line. There is coordinate geometry with respect to a circle. We are talking about a straight line. Now, first of all, why don't we recap whatever we have done so far? We went over the P1 syllabus. We talked about the distance formula, which you can see on the screen. That is the length of line segment AB. That is also the distance between 2 points. We derived the formula. We used the formula. We talked about the midpoint of line segment. We talked about slope, inclination, rise over run. And then we talked about y. If there is a horizontal line in which is parallel to x-axis, y is the gradient 0. We talked about if it's a perpendicular line, y is the gradient undefined. We talked about the different formats of equation of a line. And then we calculated equation of a line in different formats. That was equation 1. That was lecture 1. And then in lecture 2, we talked about parallel lines. Equation of a line parallel to a given line, perpendicular lines, gradient multiplied to give you -1. Parallel lines, gradients are the same. Make sure it's in the standard form, y is equals to mx plus c. Equation of x-axis, equation of y-axis, something basic stuff. Line meets the x-axis, y coordinate is 0. Line meets the y-axis, x coordinate is 0. We found the area of a triangle. We found where this perpendicular, this one over here, meets this line, and then we found this distance. And simultaneous equation was used. Area of a triangle, half base into height, different formats. Alternative approach of finding the perpendicular distance from origin to this point. So if I take this triangle, if I take this as the base and this as the height, versus I take this as the height and this whole thing as the base, and that is what was used in the previous question. And rationalization, getting rid of square root from the denominator, that was done so that I can make it obvious that the two answers are exactly the same. So now in lecture number 3, what are we focusing on? So let's focus on something that we have not studied so far. Let's talk about a parallelogram. Now, as the name suggests, what is a parallelogram? First of all, how does it look? So let me draw two lines. Over here, let me draw in blue. A line like this, a line like this, and then let me draw two lines like this. So this is a perfect example of a parallelogram. I have labeled this thing as A, B, C, D. I have labeled it anti-clockwise. So this is anti-clockwise. And as the name suggests, opposite sides are parallel. Not only are they parallel, they are equal in length. So therefore, these two opposite sides are parallel. These two sides are parallel. This length AD equals to CB. This length DC equals to AB. So let me write it down. So I'll write AD is equals to BC. I'll write DC equals to AB. This is in terms of length. And in terms of being parallel, I'll write AD, gradient of AD is the same thing as gradient of BC, and gradient of AB is the same thing as gradient of DC. This is just a rough diagram. Now, what constitutes a parallelogram? If I take a rectangle, that is a parallelogram. If I push it sideways, it becomes a parallelogram. If I take a square, I give it a push sideways, it becomes a rhombus. So all these four dots that I'll mark, 1, 2, 3, 4, these all four are parallelogram. So yes, it's a quadrilateral, and in which opposite sides are parallel as well as equal in length. Now, are there any quadrilaterals which are not parallelogram? Quadrilaterals which are not parallelogram? Yes, there are the two obvious one. What are they? That is kite and that is a trapezium. They are a quadrilateral, but they are not parallelogram because they don't have opposite sides parallel as well as equal. So I think that is the basic definition of a parallelogram. So now let me draw some lines, and just to give you an idea, drawn a line like this, and let me just copy this. So I'll just copy it, I'll paste something like this. Okay, now let me draw a line like this. Let me just copy this. Let me paste it over here. Okay, so now I have labeled a shape. This is A, this is B, this is C, this is D. Let me mark A as 0, 1. Let me mark B as 5, 11, and 2 right, 4 up. So C is 7 and 15, and A is 2 right, 4 up. So D is 2 right, which is 2 and 4 up. So I have labeled a parallelogram. And first of all, I would like you to check it out, whether it's really a parallelogram. Maybe I've made a mistake in labeling the points. So how would you check my working? So you would check my working with this. That is, are these two sides parallel as well as equal in length? So first of all, I have A, which is 0, 1. I have B, which is 5, 11. Let me calculate the gradient of AB. So gradient of AB, that is 1 minus 11, 0 minus 5, negative 10, negative 5, which comes out to be positive 2. Let me choose D and C. So this is 2, 5, 7, 15. D is 2, 5, C is 7, 15. So gradient of DC, that is 5 minus 15, 2 minus 7, negative 10, negative 5, that is again plus 2. So I have yes proved that gradient of AB is the same thing as gradient of DC. Therefore, opposite sides are parallel. Let me also work this out. AD, so this is A, 0, 1. This is D, which is 2, 5. And BC, 5, 11, 7, 15. 5, 11, 7, 15. Let me calculate the gradient of AD, which is 1 minus 5, 0 minus 2, negative 5, negative 2, leave it as it is, that is positive 5 over 2. Over here, gradient of BC, that is 11 minus 15 divided by 5 minus 7. That is 1 minus 5 is 4. My bad. Let me correct myself. So hold for a second. I can simplify. This is negative 4, negative 2. That is positive 2. So this is negative 4, negative 2. That is again positive 2. So AD and BC are also parallel. AD is equal to BC. Therefore, again AD is parallel to BC. And let me just erase this thing and I'll write AB is parallel to DC. And similarly, if I calculate the length, it will come out to be the same. Now, first of all, let me just shift it over here and like this. No, not this. Okay, this goes over here. This goes over here. And let me take this whole thing on the next page. And now I'll do something else. Okay, there it is. Copy. Now what I'll do is that let's talk about the two diagonals. Excuse me. So let me draw a line starting from A all the way till C. So this is A, this is C. So let me focus on this. So this is A, this is C. So we have A, which is 0, 1. We have C, which is 7, 15. Now let me draw another diagonal in purple. So over here, a diagonal in purple like this. Not that thick. So now I'm focusing on B, I'm focusing on D. So therefore I'm focusing on B, I'm focusing on D. So B is 5, 11, D is 2, 5. Now they're intersecting at a point, let's call it M. Let me calculate midpoint of A and C. Let me calculate midpoint of B and D. So let me just check one thing. If everything is all good, all clear, all good. So therefore, M, this is 0 plus 7 divided by 2, 1 plus 15 divided by 2. Over here, M is 5 plus 2 divided by 2, 11 plus 5 divided by 2. Let me just use some color. This is 0, this is 7. So this is 0 and 7. This is 5, this is 2, this is 5, this is 2. And over here, this is 1, this is 15, this is 1, this is 15, this is 11, this is 5, this is 11, this is 5. Now, are these answers the same? Yes, they are. This is 7 over 2, this is 8. This is M, this is 7 over 2, and this is 8. So what have we proven? We have proven that, let me just make a big heading out of it. The midpoints of diagonals in a parallelogram, that's how I write it, is the same. So if I have labeled it correctly, that's A and B and C and D. So the first and the third, that's a diagonal. And second and fourth, that's another diagonal. So the midpoint is the same. Now, how can this be useful? Let's make a question out of it. I have again wrote it like this. And let me just change the numbers. So instead of A, B, C, D, let me write P, Q, R, and S. Let me make this unknown. So this is question mark, and let me also change this. So this is P, this is Q, this is R, this is S, and let me make it into an exam type question. So exam type question, ETQ. The question would say that, let me just write it over here, PQRS is a parallelogram. coordinates of P, Q, and R are known. Find coordinates of S. So S is unknown. So let me just write X and Y over here. This is X, this is Y. Now focus, that is, focus on P. Actually, let me draw the thing. No, not over here, the other one, the green one, like this. This is one diagonal. So let me focus on P and R. This is the other diagonal, that is S and Q. So that is S and Q. So therefore, let me write P01, QR, that is 715, and then Q is 511, and then S is XY. So since they are the diagonals, the midpoint is the same. So midpoint of PR should be the same thing as midpoint of QS. So focus on the red color, that's the X coordinate, that's the X coordinate, X coordinate, X coordinate. Make sure you write in the proper order. So 0 plus 7 divided by 2 should equal 5 plus X divided by 2. Does it make sense? The average of X coordinate should equal average of the X coordinate from the other diagonal. So that is one thing that I've done. So this is for basically the X coordinates. So this is X coordinates. And if I talk about the Y coordinate, this is 1, this is 15, this is 11, this is Y. So Y coordinates, so they average. So let me write average over here. Let me write average over here because average is related to midpoint. So therefore, I'll write 1 plus 15 divided by 2. This is 11 plus Y divided by 2. Now the good thing is, this 2's and these 2's cancel out. So 7 is 5 plus X, therefore X comes out to be 2. And 1 plus 5 is 16, is 11 plus Y, Y comes out to be 5. Therefore, the coordinates of S, the X and the Y coordinate, that is 2, 5, which of course exactly is the same one that we worked with. We wrote D, this thing as D, ABCD, and over here is PQRS. That's how quickly you can take a worked example and convert it into an exam type question. Now, is this good, all clear? Just acknowledge it on your WhatsApp or just message me personally. I'll just pause the recording for some time. So now let's move on. Let's talk about the concept of perpendicular bisector. Perpendicular bisector. Now, what is a perpendicular bisector? As the name suggests, not only will it be perpendicular, it will also be bisecting it. Now, in O levels, loci, you have studied that you have 2 points. Let's say one point is over here, one point is over here, and you drew a perpendicular bisector. You take a compass, you open more than half. So let's say this is a compass, and then you open more than half, and then you draw an arc, This is just a rough thing. And then you draw one arc over here, one arc over here. You join these 2 points. And when you join these 2 points, whatever the length of the line is, that is divided equally. That's how you draw a perpendicular bisector. Now, from the perspective of coordinate geometry, we have to take care of perpendicular thing. Remember the word negative reciprocal. And also remember the concept of midpoint. So these 2 things are necessary for you to get the equation of perpendicular bisector. So let's get started. Let's say I have an equation like this, and this is a point A, 0, 1. This is a point B, and let me choose 6, 11. So now I'm interested in finding equation of perpendicular bisector of AB. Now the first thing is, let me write A and B again. So A is 0, 1, B is 6, 11. Let me find M, the midpoint, 0 plus 6 divided by 2, 1 plus 11 divided by 2. So M is 6 over 2, that is 3, and 12 over 2, which is 6. That's the midpoint. So that is the first step, that is finding midpoint. The second step, that is finding the slope gradient of AB, that is 1 minus 11 over 0 minus 6. 1 minus 11 is negative 10, 0 minus 6 is negative 6, that comes out to be 5 over 3. That is the gradient of this line. Now this line will be passing through the midpoint and it will be perpendicular to this. It's going like this. If I draw it the loci style, that's how it would look like. But I'm not interested in drawing. I'm interested in getting it from calculation. So now equation of green line, equation of perpendicular bisector should be negative reciprocal. So that would be negative 3 over 5. It was positive, it became negative, and it flipped. So use M, use this gradient, find the equation of perpendicular bisector. So therefore I'll write y minus y1 is equals to mx minus x1. Therefore y minus y1, this is y1, which is 6, is equals to m, which is negative 3/5 x minus 3. That is the equation of perpendicular bisector. Just have a good look at it. So we found the midpoint. That is step number 1. Let me write it. Step 1, that is the midpoint. Step 2, that is the slope of given line. And then there is step 3. Let me write it and highlight it. So this is step 3, gradient of perpendicular. And this is step 4, that is equation of perpendicular bisector. And that's all the basic step that you need to do. Now you have seen so far that the usage of calculator is a minimum. Maybe in some place you might need to find the area or perimeter. You might be using it very partially, but as such, it's about simplification, it's about calculation, it's about the thinking process, critical thinking, analyzing the data, writing things where it belongs, and then just proceeding it. So that is the basic idea. Now, let me go to the past paper and let me take out a question and let's see how we can proceed. So first of all, if you see the questions over here, let me talk about this thing. That is something like question number 10. There is a lot of variety in it. So let's just go very slow on this. So this is question number 10. And let me solve one question and then I'll give you some questions to try. So this is exercise 1. So let me just highlight. This is coordinate geometry, exercise 1. And we are starting with this question. Now it says points A, B, and C have coordinates. This is A and this is B and this is C respectively. Find the coordinates of the midpoint of AB. So part 1, write A again, 2, 5. Write B again, 5 and negative 1. M is the midpoint. Take the average, 2 plus 5 divided by 2. 5 plus negative 1 divided by 2. Use brackets as much as possible. So this M comes out to be 7 over 2 and this is 4 over 2, which is 2. So that's the answer of the first part. Now second part, find the equation of the line through C perpendicular to AB. So let me write A again, 2, 5. Let me write B, 5, negative 1. Gradient of AB, that is 5 minus minus 1 over 2 minus 5. That is 6 over negative 3, which comes out to be negative 2. We are interested in the equation of a line through C perpendicular to AB. So therefore, gradient of perpendicular should be positive half. Remember the word negative reciprocal. So now we have this. We have the coordinates of C. It's not a perpendicular bisector. It's a perpendicular but passing through some other point. So therefore, C is how much? That is 8, 6. So therefore, equation would be y minus y1. So this is y minus y1 is equals to mx minus x1. Y minus 6 is equals to half x minus 8. Now over here, the equation is found, but it's asking in a particular form like we discussed in the second lecture. You want x term, y term, constant all on the left hand side and the right hand side to be 0. So what we do is that we cross multiply, or we multiply throughout by 2. 2y minus 12 is equals to x minus 8. And write a 0 over here. This is x minus 2y minus 8 plus 12. This is x minus 2y minus 8 plus 12 is positive 4 equals to 0. So that is of the form ax plus by plus c equals to 0. What is a? 1. What is b? Negative 2. What is c? Negative 4. Now if someone writes this the other way around, what about negative x plus 2y minus 4 equal to 0? Will this be marked as correct? The answer is yes, this is also good. This is also good. Over here, a is negative 1, b is positive 2, c is negative 4. This is also correct, and this is also correct. So this is the question that I've done for you. Let me select a question. I want you people to try it out. So let me just paste this thing. And that's a good question to start with. So let me just write it over here. You can have a good look at it. Let me pause the recording and I'll be back in 5 minutes, and then we can continue. Chalaji, let's look at this question. The question says the line L1 passes through the point A and B. So let me focus on this. Line L1 passes through the points A and B. Then there is line L2, it's parallel to L1 and it passes through the origin. So that is the basic idea that's given so far. And then there is a point C. It lies on L2 such that AC is perpendicular to L2. So we are talking about 3 lines over here. First of all, let's talk about AB. So this is A and this is B. This is 10, 9. This is 2, 5. This is L1. Gradient of line 1, that is 9 minus 5, 10 minus 2. This is 4, this is 8, that comes out to be half. That is the first thing. Second thing, that is the line is parallel to L2. So there is a line L2 over here. It's passing through the origin. It's going like this. So this is 0, 0, and it's parallel to line 1. So M1 and M2 is the same. Therefore, M2 is also half. If I am interested in equation of line L2, I'll write y is equals to mx plus c. It's passing through the origin, therefore c is 0. This is the y-intercept. The value of m is half. So therefore y is equals to half x. That's the equation of line L2. Now it further says, let me just copy this thing, or let me just draw it. So now this is L2. This is origin 0, 0. This is L2. And then it says that there is a line, there is a point C on L2. So let's say there is a point C on L2 such that AC is perpendicular to L2. It's not a perpendicular bisector. It is just a line which is perpendicular like this. So therefore, this is A. What is A? A is 2, 5. So 2, 5 is perpendicular to line 2. That means I need to find C by simultaneous equation. So therefore, for the line AC, the line in green, I'll say gradient of AC should be -2. Why? Because of the word of the concept negative reciprocal. If two lines are perpendicular, one gradient is the negative reciprocal of the other. And it's passing through A. A is 2, 5. Therefore, the equation of AC should be y minus y1 is equals to mx minus x1. Y minus 5 is equals to -2x minus 2. -2x plus 4, y minus 5. Y is equals to -2x plus 4 plus 5 plus 9. That is the equation of line AC. That's right away. So now, in order to find this point of intersection between AC and this line, we have to solve simultaneously. So let me write this. Y is equals to -2x plus 9. That is equation AC. The blue line, that is y is equals to half x. Point of intersection, that can be done using solving the two equations simultaneously. So therefore, half x, this equals to y. This also equals to y minus 2x plus 9. And let's multiply by 2. So x is equals to -4x plus 18. Therefore, 5x is equals to 18. Therefore, x is 18 over 5, which is 3 whole 3 over 5, which is 3.6. Y comes out to be 2x, that is 2 times 18 over 5, or 2 times 3.6, that comes out to be 7.2. Therefore, coordinate of C is 3.6, 7.2. And last but not the least, that is A, which is 2.5, C, which is 3.6, 7.2. We are interested in the distance between A and C, magnitude of the line segment. That is 3.6 minus 2 whole square. This is 7.2 minus 5 whole square, square root. This is 1.6 square. This is 2.2 square, square root. Let's use the calculator and let me just grab the answer from here. So therefore, this comes out to be 1.6 and 3.2. So it's half x, my bad. I just made a small mistake. I don't know where this 2 keeps on popping. So this is half x, this is half, and this is half, and this needs to be changed. Hold for a second. So therefore, this is half x, the blue line. This is half of 3.6. This is 1.8. This is 1.8. This is 1.8. 3.6 minus 2, 1.8 minus 5. That is -3.2 whole square. And the final answer is coming out to be 3.58 after the square root. And this is correct to 3 significant figures. So that's how this question is done. That completes lecture 3 of coordinate geometry. Till the next class, take care.